Couple of definitions to start off this section. So the first one is a new word. So an irrational number, I-R-R-A-T-I-O-N-A-L number, is a number that cannot be written as a quotient of two integers. In other words, it cannot be written as a fraction. Everything we've dealt with so far, up until this unit, has been a rational number, something that could potentially be written as a fraction. So the decimal form of an irrational number neither terminates nor repeats. That means it doesn't end ever, nor does it have the same number repeated over and over and over, or even the same series of numbers repeated over and over and over. So, for example, the irrational number below, the patterns of 1 are separated by an increasing number of zeros. So, like, you'll see it goes 1, 0, then 1, 0, 0, then 1, 0, 0, 0, and then keeps adding zeros. But there's no repeating pattern there. I mean, yes, there is sort of a pattern, but it does not repeat. So we call that an irrational number. Now, the next definition we need is the real numbers. Now, real numbers are pretty much any number you can think of. So any number we just looked at in terms of square roots, whether it's like the square root of 27, which is not a nice number, it ends up being 3 times the square root of 3. That's a real number, even though it has a real or a whole part and also a square root part. But the real numbers consist of all the rational numbers, all the stuff we've done before this unit, and all irrational numbers, all those square roots that we can't simplify. So this Venn diagram shows the relationship among the real numbers. So on each side, we've got real numbers is everything. And irrational numbers, that's like the square root of 2 or the square root of 7. Or you might have seen this symbol, pi. That's another irrational number. It never ends and doesn't repeat. Rational numbers, on the other side, those are fractions like 3 over 4, 1.5, everything that can be written as a fraction. Integers, those are like -4, 3, -3, really anything positive and negative that doesn't have a decimal. And whole numbers, those are just anything that you're counting, or you can have like 0, 1, 2, 3. So anything in the whole numbers is also an integer, which is also in the rational numbers, which is also in the real numbers. So anything inside of this area right here is also inside of this area right here, and is also inside of this area right here. It's kind of like, say you live in Grand Rapids, which is in Michigan. So you're still part of Grand Rapids, but you're still part of Michigan, and you're still part of the United States, and you're still part of North America. So it's just kind of like you're expanding, getting bigger and bigger and bigger.